Right, thanks all for coming along. This talk is called AssertTrue, isDecoupled, My Tests. I'm Dave Liddament. It's my first time ever at DPC, so I'm pretty excited, and it's my first year of conference talks. So we'll see how we get on. I'm pretty nervous. My heart rate's already over 100. Right. So the whole point of this is decouple tests. If we decouple our tests, we reduce the development and maintenance costs of our test suite. And the reason we want low-cost test suites is if we think of a value of tests, it's the cost of the bugs found by the tests minus the effort of having the cost, minus the cost of the test suite. So bugs obviously cost money in terms of cost to fix the bug, reputational damage, maybe you have to refund your customers. But test suites also cost money in terms of actually writing the tests, running them, and keeping them maintained. So as long as we save more money than the test suite costs, there is value in doing these tests. So the lower we can have the cost of the test suite, the better. And this talk examines the ways in which you can reduce the costs of the test suite, specifically around decoupling our tests from the code we are testing. So I'm going to start off with what we may or may not get out of this talk, because there are 4 other amazing talks going on right now, and I want to make sure that you are at the correct one. So this talk is for you if you probably have to have done some testing to get something out of it. If you've never done any testing, bits of this might not make sense. And if you want something that's quite high-level overview concepts that you can apply to testing, specifically if we're testing at the UI level or the integration level. So that's kind of where we are. It's all quite high level, quite abstract. It's probably not for you. It's probably not for you if you are an experienced tester and you are already testing your whole software stack. And if you know things like page objects and service layers and architecture like layered architecture and hexagonal architecture, that's what the kind of stuff we're going to cover at a very high level here. And if you don't like abstract talks, this probably isn't the one for you either. So if that's not for you, now's the time to do a runner. But you're more than welcome to stay, so thank you for staying. So with the admin out of the way, quick introduction. I'm Dave Liddament. You can find me on Twitter at Dave Liddament. For a job, I work with a couple of others. I run a software consultancy called Lamp Bristol, based in Bristol in the UK. When I'm not at work, you might find me running or scuba diving. That's a picture of me diving in the Scilly Isles. I also organise a couple of meetups, PHP Southwest and Bristol PHP training. So if you're ever over in the UK, do check us out. And finally, I've been working in the industry for maybe 15 years in various languages. And I'm quite fortunate because probably about half that time, I was working on projects where there was some kind of automated testing going on. And it's that time that I learned quite a bit working on these projects, and it's kind of these battle scars from testing that I'm going to share with you today. And I've got 3 stories, and most of the stuff I learned the hard way, and my hope here is to give you some of the information so it's not quite as painful for you. But before we look at these stories, we'll have a quick discussion more about why, and we'll also cover some terminology as well. So most of the time, I think testing is great, and I have a nice, warm, fuzzy feeling that I've got all these tests and they run, and every so often they fail and they tell me something that I've missed, and I'm really, really generally quite happy with testing. But once in a while, I really hate my test suite, And one such time is when I make what seems like quite a small change to the functionality, and that change that's being requested, well, it's one small step for the code base, but it's one giant leap for the test suite. And what happens, how that's manifests itself, we have all these tests, they're all passing, and I make this tiny little change, and like half the test suite goes red, and there were lots of test failures, sad face. And this is bad because potentially every single one of these tests we've got to go and look at and work out what's gone wrong, and maybe we potentially have to do a fix to every single one of these. And it's situations like this that the maintenance cost of our test suite kind of rockets upwards. So now it's confession time. I've written tests, that's a good thing. And once, or more than once, I've been near a deadline, I updated code, and the tests broke. And then I looked at the tests, and I realized that even though they'd failed, I was like 99% sure that actually the code was working and the issue was just something with the test. But a lot of them have failed, so it's going to take quite a lot of effort to fix all these tests. And my confession is that rather than fixing the tests, I marked them as ignored. So PHP unit won't run them. And this is fine, because I knew that I would go back and definitely fix these tests later when I had time. Now, I've got another confession. I have some of these tests, and they've been marked as ignored for over 6 months. Not good. In fact, I've got another confession that some of those tests have been marked as ignored for over a year, and I'm going to stop with any more confessions now, because what am I doing? And this is obviously really bad. Those tests were there for a reason, and before they were ignored, they were protecting me from some kind of future regression. And because those tests are ignored, so PHP is not going to run them, I no longer have that safety check. And one day, I or another developer will update some code, and they will introduce a bug that would have been caught by one of these ignored tests, and that bug will slip into the system. We won't catch it because the test isn't there to catch it. But one of the main reasons I didn't fix these tests when I should have was because the test code was just too tightly coupled to the software under test. And I just didn't have time. So that's why we want to reduce our coupling between our test code and our software under test. So that's enough of confessions. What about terminology? So imagine we have two objects, A and B, and the coupling between these two objects or two functions is the degree in which one of them knows about the workings of another. So here, A doesn't even talk to B, so there's no coupling at all. Generally in software, we have to have some kind of coupling. So, the objects or functions have to interact with each other, otherwise they're just doing two completely separate things. So suppose A was an application and B is an email gateway responsible for sending email. So our ideal situation is when the application A wants to send an email, it just knows about the interface to B, the email gateway. And it'll just say, look, send this message to this email address, and that's all it has to do. The application knows nothing about how the email gateway actually sends the email. Does it send it via SMTP? Does it use an API like Mailgun? Does it put the message on a queue to be processed later? The application doesn't know. The application doesn't care. And in this situation, these two things are, well, it could be said there's low coupling between them. They're loosely coupled. Only really knows about the interface, and generally this is a good thing. And there's lots of everyday objects where we interact with, and there's quite low coupling with them. For example, I have no idea how my car really works, how the engine management system works. It doesn't matter. I know the interface to my car, so I can drive it. It doesn't matter what really goes on behind the scenes. So that's good. There's low coupling between me and my car. Now, back to software, suppose through poor design that our application actually the application needed to know the internals about the email gateway. Perhaps it needed to know the transport mechanism for the how we're sending the emails, or maybe it needed to know some credentials. Now, A and B are becoming a lot more tightly coupled. So we need to know what's going on inside in B, and that means if we make an update to B, potentially we have to update A as well. And if other things are tightly coupled to A, then potentially we have to update those as well. So doing a change over here could ripple through our system when we have to change something over there, and it might not really be very obvious. So this is tightly coupled, or there's high coupling, and this generally is a bad thing. So a bit of a silly example, really. Coupling is a bit like your favorite junk food. The less you know about what's going inside it, the better. So test doubles is another thing I want to quickly introduce. if we have an application, A, and it wants to send emails, in our real test environment, we probably don't really want to send emails. Instead, we want to have some other kind of test double. So a test double is something that looks exactly the same, but it doesn't behave in that same way. So potentially, instead of actually sending emails, it just remembers, say, that an email had been sent, and it stores that for later. So what we can do is, if we have low coupling between the application and the email gateway, it means it's very easy to replace the email gateway with something else, like, in this case, a test double. So this is another reason why low coupling is good in the code that we do, because it's very easy when we come to testing to replace bits of the system. The final thing I want to have a look at is something called the test pyramid, which we've probably seen before. And it's just a way of thinking about the different kinds of automated tests, the different kinds of levels of automated tests that we need to create an effective test suite. So at the top, we've got the UI, then we've got integration, and then we've got unit. And when I say UI, that means we are testing the application via the UI. That doesn't mean they are UI tests. It means we're using the user interface to test our application. If we're at the integration level, we're using something at the integration level to test our application. And generally, as a rule of thumb, unit tests are quick to write, they don't cost much, and they're very quick to run and cheap to maintain. Whereas as we go up the pyramid, testing via the user interface, as we'll see in a minute, is high cost and slow and difficult to maintain. So the reason we want more tests at the unit level is because they are cheaper and quicker, but we still need things all the way up the pyramid. Okay, so remember that the whole point of this is decoupled tests reduce the development and maintenance costs of the test suite. This is why we're here. So we've done some terminology, we've talked about why. Let's have our first story. So my first story is about an application where people had to complete lots of multiple choice quizzes. They're kind of work related. And every few months, new quizzes were released. Now each person belonged to a team, and teams were classified as things like by their location and their job function. And from time to time, people moved between teams. So when a person completed a quiz, their score had to be assigned to the team they were in at the time. And it was all a bit of fun, but there were prizes for teams who had the highest scores and the highest participation. So it was a bit of a competition. So typically, a user journey would be Bob wants to participate in a quiz, so he would log in, he would see a list of quizzes, he would pick one he hadn't done, he would complete the quiz, he would see his score, and his team score would be updated. Now, initially, we had lots and lots of code written, and we were doing all our testing via the web interface manually. And it turned out this was quite painful, so we had to start automating it, because it was just taking too long to test manually via the user interface. So in some respects, testing by the user interface is probably ideal in terms of decoupling, because we could throw our entire implementation and we could rewrite it in a completely different language, and as long as the test passed, we knew that our application was right. So arguably, you could say testing at the UI from a decoupling point of view is the best possible place to test. However, as we'll see, there are lots of issues with it. So it's first time testing this, and initially my test kind of looked like this. So I'd say visit the home page, find a login link, click on the link, find the form with the element username, put in the username, find the password thing, do this and do this. And I was using Selenium, so this was kind of scripted. And there's quite a few problems with this. First of all, just reading through this, it's not really obvious what we're testing. We're just kind of interacting with our user interface. And also, these tests would be quite fragile. So what if somebody came along and said, I just want to do this tiny change. I just want to change something about the layout of the pages that lists all the quizzes. So you kind of make that change, and then we're at the situation where all of the tests fail again. And this kind of comes back to my confession. I know all I'd done was I just updated the ID of a field, and then all of the tests broke, and I knew that really everything was working fine. It's just I had to go through all these tests and change things. So that's why when I started down this route, I thought, well, it's okay to ignore these failing tests. But it's not really. So, and this is basically the problem with testing application functionality via the user interface. So we have decoupled ourselves completely from the implementation, but instead we've coupled ourselves to what is the most fragile part of a software system in general, the user interface. And it's all come down to this tight coupling. You know, if I make one bit of change to the software under test, then suddenly, potentially, all my tests fail because the change ripples through the whole system. So, as is always the case, I think whenever I've got a problem, someone else has already had that problem and they've already solved it. So, what had other people done? What they'd done is they'd put something between the tests and the software under test, and one solution offered was something called a page object. So a page object wraps an HTML, like a page or maybe a fragment of a page, and it provides it with a nice clean interface that our tests can use. So our tests, instead of manipulating software under test directly, they go via the page object. So our tests will talk to the page object in terms of things like, I want you to log in using this username and password, or I want to answer this question. And our page object talks to software under test in terms of, I want to find an element on the page, I want to click on this thing, I want to put some data into that text box. And generally, page objects kind of do three things. They simulate an action that a human would do. Maybe they'll grab data from the page, or maybe they'll navigate to another page. And when I say page, I don't necessarily mean a whole page. It could be like, you know, you could be on the home page and say, I want to get the login page, and that's just a little bit at the top with, you know, the username and password bit. So they wouldn't necessarily map one-to-one on pages. It could be bits of a page. So the way in which we've reduced the coupling between our test and our software under test is that if we do something which makes a change to our software under test, just a little change, like maybe we've renamed an element there, then all we do is we just update the page object bit. So whereas before it was talking to the element was username, now the element is email. We just update the one page object and the test remains the same. It hasn't changed. So we're still talking about things like we're logging in, and just because something about how the login process has changed, we don't need to update our test, it's just the page object. And the reason for this is, in reality, if it's just a single test talking to the page object, there'd be no point doing this. But the reality is we have multiple tests, and they're all going to interact with the same bit of the software under test. So they'll all be talking via the same page object, and that means we're just isolating changes to one place. So when something changes, we've just got to update it in the page object. So now our tests look a bit more like this. We get our login page, then we try and log in, and the response from once we've successfully logged in is we get a page object that has a list of all the quizzes. We find the quiz that we want to do, we fill in the answers, we submit the answers, and then we check the score. So that's a lot better because we've kind of we are quite more resilient to changes to the UI. But this test is still quite detailed, and I can't immediately see what the point of it is. The questions I really want to ask are questions like this. Does an individual score get assigned or allocated correctly to the team they were in? These are kind of the business level questions I'm really asking. And from those kind of UI tests, it's still not quite obvious that that's what we're doing. And the other thing is people might still come along and say, I just want to do this tiny little, what is essentially a tiny little change. When we log in now, instead of going to a page that shows all the quizzes that user's done, we want to go off somewhere different. And the problem with making this change is that this line here will fail in the test. And in fact, any test that goes to a login and then expects there to be presented with a page of the person's quiz results, any of those tests will fail. So we're kind of still in the situation where one or two changes might lead us to this situation. So we can reduce decoupling further by essentially putting another layer between the tests, and this time between the page objects. So I've called this the DSL, the domain-specific language layer. And here, this is talking in the language of whatever business domain we're working with. So it might be talking in terms of, right, we're submitting a user's answers, we're getting the test scores. So our test will say, I want you to submit this user's answers for this quiz. And the DSL layer would go, fine, I need to talk to this page object to log in this particular user. Then I need to use this page object to navigate to the quiz I want to see. And then I'm going to use this page object to actually put in these answers for that user. So it's just an extra layer of abstraction, really. And then our tests are starting to look a bit more like this. We're assigning a user to a team, we're submitting a particular user's answers, we're getting the team score, and we're checking that is what we expect it to be. And now this is a lot closer to the actual business requirement here. You know, is the individual score getting correctly allocated to their team? And you can look at this, I've kind of highlighted the interactions we have with the DSL layer, and you can see that that is far closer to the language of whatever business problem we're trying to solve. So this is kind of now what it looks like. And essentially, the key takeaway from this is we have some abstraction between our tests and between the software that we're testing. And all we're really doing is we're just really applying the same good practices we would when we're developing code to our test suite. So if you think about things like single responsibility principle, each page object is responsible for just one thing, like the interaction to log into a page. And then our DSL layer, it doesn't ever interact directly with the software under test. It just interacts with whichever page objects are required to do the job. And then finally, our tests are just saying, I want to do things, and they're stating them in quite high-level business talk. And the only reason for tests now to change is if we've fundamentally changed a business requirement. So the moral of story one is testing an application's business logic via the user interface is difficult, time-consuming, and it requires a lot of effort. So what we need to do is introduce layers between the software under test, and that's to reduce the coupling between our test and what we're testing. And we're doing this basically by isolating changes. So if we do get changes, there's one or two places we need to update them rather than every single test. And importantly, the tests don't change unless the business requirements actually change. And not really a takeaway for anyone else, but for me, I don't really like doing this kind of testing. So I moved very much to back-end stuff now. So this was the reason for the talk. And hopefully you can see how if we start doing our UI testing like this, we can get some of the benefits by reducing development and maintenance costs. But we've got 3 stories, so we need a cliffhanger to keep you entertained, ready for story 2. So what if we replace the entire website with an app? Suddenly, all these tests we'd have to throw away, and there would be no tests anymore. And generally also, this does feel like a lot of effort. So story 2, I'm taking a bit of poetic license. Actually, all the stuff that I'm talking about story 2 was on a different project, but to save having to introduce a whole new project, we'll just pretend it happened on our quiz project. And there's essentially 2 extra bits we've got now, that before you want to start entering quizzes, you have to make a payment, and then also every time you submit your quiz, you get an email telling you the results. So our system looks a bit more like this. We've got a web interface, we've got the software, and it goes off and talks to payment gateways and sends emails somehow. And initially, I assumed I don't really know what's going inside this. This is kind of a black box, although in this screen it's a purple circle. But anyway, we don't know what's going on inside there. So if this really is the case, then we have no other option but to interact with the system in the way we've looked at. But I kind of thought there's got to be a better way to this. So I read around the subject, and people started talking about how if you design code for testability, surprisingly makes testability a lot easier. And kind of at these high-level things, there's things like layered architecture and hexagonal architecture. Now, those topics themselves are massive, and there'll be talks in themselves, so I'm just going to kind of talk at it at a quite high level rather than going into intricate details. So what we really want is we need to push all our business logic to the center. So anything that's specific to whatever business problem we're solving, that lives in the center, in the blue blob. Then we've kind of got a layer around this called the service layer, and then that sits within whatever framework we're using, and it's the framework's responsibility to interact with the real world and then pass off stuff to the business logic to deal with. So, and the golden rule is the inner layers know nothing about the outer layers. So the business logic has no idea that it is currently in a web application. It's just logic that's solving whatever business problem we need. So a service layer will have lots of classes or interfaces that look like this, and they're talking a lot closer to the language of whatever problem we're trying to solve. We're trying to submit a user's answers. That's what it's doing. And we'll have lots of interfaces like this. So rather than testing now via the user interface, we can test at the integration level, at this service layer. And we'll see that this is a lot easier. So there's one question you might have asked. Okay, so that's fine. I can see how people interact with the business logic, but how does the business logic then go and do things like send emails and make payments? So there's kind of an extra bit to this, really. The business logic does know about interfaces to do things. So we've got a payment gateway interface and an email gateway interface. But it only knows the interface. It doesn't know how that's actually implemented. So our email gateway implementation might look somewhere like this. It's like something like this. It's pretty simple. It's just saying that I want you to send an email, and I'm saying here's who you're sending it to, who it's from, here's the subject, here's a message. Now, the real implementation is the yellow boxes, which are marked as adapters, so the bottom right for the email and top right for the payment gateway. But the business logic doesn't know anything about these implementations. It just knows it's got something that conforms with the interface we've just seen. Now, for testing, we don't really want to we don't want to actually make real payments. They get quite expensive every time we run our test suite. And we don't really want to send real emails. We just can do something like this. We can just remember, we can have, say, an email gateway spy, and all that does is every time we send an email, we just store it like locally in an array, and then we've got a way of interrogating all the emails that would have been sent. So our tests can go, right, what emails were sent, have all the ones I expect to be been sent. So when we get to testing, things are generally a lot easier now, because the language of our tests and the language of our service layer are pretty similar. So our test might talk about submitting users' answers, and we might actually have something on the service layer which actually is submit users' answers. So our layer between these two things is quite thin, and maybe you don't even need it at all. And more generally, if we think about how we were testing before, we've got all these external things, like we're talking, our web, we have to talk, in HTTP, in HTML basically. We've rendered all this HTML that we've got to look at and inspect and interact with. And then there'd be things which we never really addressed. I mean, how would we check emails were sent? How would we check payments were made? But actually, testing at the service layer is easy, because we can replace all of those things, and our test entry point now talks straight to the business logic via the service layer. And instead of actually sending emails and actually making payments, we just have test doubles, and they can just remember all the requests made to these things. And this, hopefully, looks a lot easier to test than what we were doing before, where our test entry point was the outside world. And then we'd have to worry about all these things. So the problem is, obviously, the big but is we actually have to start designing our software to work, to be architected in this way. And the best thing to do is to start designing your software to do this when you've got a nice greenfield project. Start building things in this manner. But the problem is, if our software starts off like this and we've not really designed it in that way, what can we really do about it? Well, we have to be basically testing at the UI level. And what we would do is we would say, look at all the places where we're talking to payment gateways. We would write an adapter to talk to our payment gateway, and then we'd have to refactor out all the places in the code to use this adapter. We do the same for any other external service that we're talking to. And then let's assume that we've got business logic in our controllers. So what we would do is we'd say, fine, we're going to start moving all this business logic from our controllers into actual business logic, and we'll have our service layer to provide access to the business logic. And we'll slowly start moving everything over till we've got a much better architecture. But whilst we're doing that, we're still testing via the user interface. And then eventually we'll have a system where everything's there, we've got a service layer for it, and then we can throw away all our existing tests and well, we can throw away the layer, all the UI stuff, and just go down to this level here. So I think testing at the integration level is much better. This is where I do a lot of my tests. I mean, I've got a lot of unit tests as well, but predominantly most of the testing I do to assert that we're doing things correctly from, all our business use cases are met is done at this layer here by a service layer. So if we're doing all this, do we still need to test via the user interface? And as a reminder, when I say testing by the user interface, it's testing that the application works correctly via the user interface. So if we're in a situation where we say, I'm pretty confident from my tests that everything's working at the service layer, at the integration level, I've got very high confidence that everything's working fine, then what we're really asking is, have we wired our user interface together correctly to the service layer? That's kind of the question we're actually asking. And that test base is a lot smaller than, is this doing the right thing from a business perspective? So what tests do we need? So probably what I do is I look at all the tests we now have at the service layer, and I'd say, what are the minimum number that we can elevate up to run at the user interface level that will give us reasonable level of confidence that everything works? Because we're not really asking, are all our business requirements met? We know they are. We're just saying, is our user interface correctly talking to the service layer? So we pick whatever ones we were. And it's a bit controversial for tests. It's kind of advocating automated testing. But then at this point, I would decide, is this worth the effort to actually have as automated tests, or do we just have them as manual tests? And that largely depends on, it's very project specific. It's kind of a function of how frequently our user interface changes. There's a few projects where most of the stuff is like an iceberg. Most of the stuff's below the waterline, and our user interface is quite simple and quite stable. So I don't automate them. I just manually test it. And also the people who do the manual testing are cheaper than the software developers. But anyway, that's kind of on a per project basis. And if you do decide that you are going to automate them, then we've kind of discussed techniques to make that reasonably pain-free. So the moral of story 2 is basically it's much easier to test our business logic at the kind of integration level rather than at the user interface level. And we are still coupling our tests to something, but we're coupling to the service layer, which is generally far more stable than our user interface. It's not going to change as much. We still do need some testing at the user interface to make sure we've wired it up correctly. But the main thing is we need to architect our code in a way that makes this testing possible. And essentially what we're doing is we're taking our business logic and we're saying it has no knowledge of the world around it. So if I was writing a web application, I might pick, I've got like all the stuff that's related to the framework, and then I'll have a level which, a namespace which is specific for all our business logic, and the rule is that cannot have any dependencies on anything to do with the framework. And also, not really of interest to anyone else, but I quite like doing this kind of testing. So we need some cliffhangers. Oh no, sorry, the cliffhangers from story 1 was, what happens if we replace our entire website with an app? Well, if we've done most of our testing like this, it doesn't really matter. We know everything works. If we are using an app instead of a web interface, then that means we will have to go around and write a test for the app, but that's fine. It's completely new code. And we also thought it felt like quite a lot of effort. Well, this hopefully is demonstrated as a lot less effort now, assuming we architect our code correctly. So this was why we were here, and hopefully you can say if we architect our code correctly and we do our tests at this level, we've certainly got a lot more stable tests and therefore a lower cost test suite. However, I've kind of got this nagging feeling that maybe I haven't decoupled everything I possibly have, which is where story 3 comes in. So generally, I'm a lot happy about how everything is being done. We've got lots of tests testing the business use cases. Everything's great. In fact, everything's going really well, but we decide we're going to expand the product that we've written. So instead of it just being for one company, it's going to offer it to multiple companies. And that means each company has their own branded page with their own subdomain, and the extra bits that are interesting for us is that we can only log in, you can only log in via your company's subdomain. So behind the scenes, our authentications change slightly. Whereas before we needed username and password, now we give the username and the subdomain of whatever page we're on. So only if all those 3 match can we successfully log in. So I implemented the code, tested all that new bit, and then I ran the code on the existing stuff. And again, we had loads and loads of failures. And we had failures for tests like this. Does an individual score get correctly allocated to the team? Why would this test suddenly start failing when we aren't really doing anything to do with that part of the code? It's been stable for months, and this is something that shouldn't really have changed. And the issue was about how I was seeding the data. So most of our tests, especially when we get to the integration level, they need data set up in a certain format at the start of the test. So for example, we might need some quizzes loaded in if we're going to test the quizzes. We might need some users and teams in the system, preset into the system. And what I was doing was I was using a tool to seed the database, and the tool basically would read the YAML files, and it would, like, you take the outer level stuff, and that's users, so it goes, I know I'm populating the users table, and this would put these 2 users into the table, and it would match all the fields up. So it would look at this, it would convert the contents into SQL statements that were inserted directly into the database. And this is not necessarily the best way of doing things, because what we're doing is we're really tightly coupling our tests to the database schema, and the database schema is most definitely implementation detail. And what happened is, as part of this work, we'd added in a new field to the user's company ID to say which company they belong to. So we had data in the database that wasn't in a valid state, so when we pulled it out, we had all kinds of trouble. So there are many reasons why we don't want to seed a database directly. One of them is actually because when we're testing, we might not be using a real database. We might be using a fake database for performance reasons. So maybe instead of something that's actually SQL behind the scenes, I've implemented it as like arrays, so it's in memory and really quick. I haven't really got time to go into that one, unfortunately. So the question is, how are we going to build these data fixtures then? So we could do what I was doing. I was seeding them directly from afar, putting them straight into the database via SQL statements. Or maybe I could hand build the objects whenever I need them, or maybe I could use patterns like the ones called the object mother or the test builder, which we'll have a look at. So hand building would be something like this. Every time we need a new user, we'll have some code which registers the user. And the problem with this is every time we make a change like the one we just made, we've got to go and find every place where we created a user, and we have to add in the extra company ID. So we don't really want to be hand building stuff that violates don't repeat yourself and lots of other bad things. So instead, we could use something called the object mother. And the object mother creates users of whatever type they are, so objects of whatever type they are. So the user object mother creates users. And if you use user stories and you have personas, so for example, often when we're developing software, we have all our stories in the context of personas. So Anna would mean something, Bob would mean something, and everyone on the team would know what they were, and if you forgot, you'd go and look at the document that described what all the personas were. So we could have things like get Anna, and then Anna would return a user in a known state, and we would all know what that meant. So kind of the implementation at quite high level was we'd say, if we've already got the user, we'll just return that. Otherwise, we'll create the user. And of course, when something comes along, like we need to change how we create users, there's just one place that we need to make this change. So kind of like what we're doing right the way in story 1, we're just isolating the points where we have to make changes to just one place. So Object Mother is essentially a factory, and Test Builder is also a kind of factory. They're just responsible for building objects in a valid state and potentially also persisting them into our database. So another way is just to use a user builder, which is following the builder pattern. So by default, you can get a builder and just say build, and it will have a whole set of default values. But with the builder pattern, you can kind of override any of the things you want. So you could update the name, you could change what team they're in, and then you finally build the object. But these are just factories, basically. They're just building things. But the important thing is that object mothers and builders will probably defer to other object mothers and builders. So actually, in the case where we're creating Anna, and we've got this extra thing, so now we need to specify what company Anna belongs to, what we can do in our user object mother is we'll say, well, we'll defer to a company object mother. We're responsible for building the company that Anna belongs to. So we can say, go and get me Acme Company. We've got the company ID, and then we can put this in here. So again, we're isolating changes, and that means if we've got really complicated objects that we need to build, we just say, look, build me this, and it knows how to build all its dependencies. So all our tests, which didn't really care whether users belong to companies or not, they don't change, because it's all encapsulated in here. And you could potentially do some kind of hybrid. So if you wanted all your data in a YAML file, because you're making lots and lots of people, you would read through the YAML file, but instead of inserting it directly into the database, you'd go via like a builder to put it in. So the moral of story 3 is basically we need to use patterns like the object mothers and the test builders for building our data fixtures, because this makes our tests more robust to change, because if we need to make updates to how we build things, object dependencies, we can just update them in one place. And that's essentially another way that we're decoupling our tests from our software under test. So remember, this was the reason for this talk. Decoupled tests reduce the development and maintenance costs of the test suite. And hopefully you can see the things we've done in story 3 will help with that. So the whole theme of this talk has basically, unsurprisingly, been decoupling. And as a summary, our first kind of decoupling, we were doing user interface tests, and we just needed to break the direct link between the tests and the software under tests with some layers in between. And those layers are there to help us protect against changes that are inconsequential to the business requirements. Then we upgraded. So we said, instead of testing at the user interface level, let's test at the integration level, and our tests are so much simpler then. We still need to do user interface ones, but not as much. And to do it that way, we had to design our code in such a way which made it easy for testing. So think things like a layered approach or hexagonal architecture. And finally, the story looked about how we create our data fixtures. We need to do it in a way that leaves our tests kind of decoupled from how we create data fixtures. So if something changes about how a data fixture, for example, a user now has a dependency on a company, all the tests which are just interested in users, they don't change. You just say, create me this user, and you'll get a user that's created and valid. So we kind of just looked at the top 2 bits of the pyramid. There are things at unit test level. In a longer talk, I could talk about them. But essentially, the one thing to look at is when you're mocking stuff, make sure you're not over-mocking your dependencies. I'd love to talk more about that, but we only have 45 minutes, and we're almost done. So decoupling is good because it reduces the development and maintenance costs. We need to do the right kind of tests at the right level, so we don't want to do most of our business tests at the service layer. And in order to do that, we need to architect our code correctly. We still need to test the UI, basically it's correctly wired up to the service layer. And we need to build objects using things like the object mother and the builder pattern. So there we go. Thank you for listening.